flood, according to the biblical description, is 40 days and 40 nights of rain, which would be phase 1, where the earth opens up like a tightly stretched cloth, okay? And this rip wraps around the earth like the seam of a baseball. And then you have 150 days of prevailing waters, according to the biblical description, which would be phase 2, where the water is no longer spraying into the atmosphere, but increasing the rising water level, causing it to go higher and higher until you reach phase 3 at the end of the flood, where the biblical description says that the waters were assuaged, and so they retreated. And that is basically why we see the earth in the condition that it is today, mostly covered in water, because all of that water was once under the crust of the earth, and it catastrophically emerged to the surface. The mid-oceanic ridge is essentially the scar that the flood left behind, because it is the place where that crack used to be that wrapped around the entire earth. The mantle, being relieved from the overlaying pressure of rock and dirt, is springing upward naturally until it reaches an equilibrium, and that's what's causing the floodwaters to retreat, because the rising mantle is pushing the crust out, causing it to buckle, fold, and compress on itself. You look at the world from a global perspective, this is what's happening, and this is what's causing the mountain ranges to form. So when the high places are exalted, the water will rush down from off of the high places into the low basins, which have been established. This is a map of all of the individual continental plates of Oklahoma. And so this is where the strata, where it may be that it's all the same strata stretching across the entire continent, or at least for hundreds of miles is just the same kind of strata. But in certain places, there's uplifts and then low basins everywhere. And so the continental plate contains hundreds of formations, each individual plate, and they all have different shapes. The Cherokee platform is basically a level plain, even though there are hills and mountains and stuff on it, or small mountains at least. It's generally a flat plain that stretches for well over 100 miles. The highest points would be Upper Permian, Leonardian strata, and so it has specific characteristics in that specific layer of strata, which contains certain fossils, that are basically exclusive to that kind of a sequence, because it's going to have multiple layers in it with multiple different minerals and stuff, like, a layer of sand and silt and clay up here, but it's all a part of the one sequence, which they've charted out. So, and it exists in reality. You have the Permian strata, and then it has certain levels within it, because certain organisms are found, and they're found in a certain order. So you're going higher in altitude, and that's how they determine certain sequences of strata. So you have, and your upper or lower, as far as that condition, and also the organisms themselves, what ecosystem you're dealing with. But the point is that you use that ecosystem as a way to determine if you're higher or lower in the strata. Now, in the Leonardian strata sequence, obviously certain fossils, which I can't think of right now, would be associated with that, but they'd be at the Permian. They'd probably be like insects, or, the upper Permian, I'm pretty sure, is the giant insect, the giant extinction event of the Carboniferous era. So, they would contain certain fossils, and then you could establish formations, in a particular area, and determine if it had that fossil, where you are in the strata, and then look at the nearby geography, and then, you put it on a chart. So Oklahoma, as we know it, the Cherokee platform is capped with this Permian rock, the upper Permian rock, and then the rest of the strata that used to be there, above it, which would contain the dinosaurs and the mammals. That's all been scoured off the face of Oklahoma, all of Oklahoma, basically, except over in the Panhandle. Here on this chart, you can see that a majority of the, eastern Oklahoma is capped with the Pennsylvanian rock, where there are a lot of places where it's capped with the Permian, which is above that, and then you go to the western half of Oklahoma, and the majority of all of that is actually the Permian rock. And so the western half of Oklahoma is a little higher than the eastern half. And you get So the Ozark uplift is capped with mostly this Pennsylvanian rock, and so even though that western half and a lot of the surrounding area around the Ozark uplift is even higher than that, consisting of Permian rock, you have this Pennsylvanian, the actual crust of the earth has uplifted with the Precambrian granitic bedrock that has been uplifted and has pushed up the crust of the earth, and all of the sedimentary rock above it, which is consistent of multiple layers, they have all bent, they bent upward, and that's what's happening here, is uplift in the actual crust of the earth, raising up low layers of strata even above the higher layers of strata, as far as how they would have originally been laid down. They'd have been laid down flat, where you have all of it on an equal level plane until it gets uplifted, and then certain portions, even though they were originally lower, it exalted higher. The Arkoma Basin, is covered on the surface mostly with Pennsylvanian strata, and the Ouachita uplift is covered mostly in Mississippian, and so that's lower layers of strata that's been exalted above upper layers of strata, just because the entire crust of the earth from the Precambrian basement rock has uplifted all of the strata, and so lower layers get exalted above higher layers. The Ouachita uplift is mostly capped with Mississippian strata, and so if you look at this chart, you can see that it's a lot lower, than what the surrounding area would have, on its surface, which is the upper strata. So it's, very clearly a movement of the entire crust upward has forced these lower layers up. The Hollis Basin, like most of Oklahoma, is covered in the Pennsylvanian strata, and then the Wichita Minor, whatever that's called, Wichita Criner uplift, been pushed up through, all of the other strata and been exposed. And so the actual continental plate, a major portion of these sequences of strata, have been buckled and compressed and then uplifted. And so you have these lower layers of strata, as they're being uplifted, it's creating flat edges and surfaces, different shapes, that are being exposed on the surface. Cross-section of the Anadarko Basin reveals that the strata was originally laid down, horizontally. It was all flat, and then tectonic plate movements caused the crust of the earth to buckle and compress, forcing the formation of modern mountain ranges, the uplifting of the crust of the earth. The surface of the Panhandle, called the Anadarko Shelf, mostly consists of Cenozoic layers, but most of Oklahoma probably had a surface area of a lot of this Cenozoic rock layers until they were removed by thousands of years of erosion since the flood has occurred. So So before the flood, here's an image of what it could have looked like, with a lot of it being capped with the Cenozoic layers containing mammals, and then the other half consisting of Cretaceous rock covering the surface, whereas over, 3,500 years, 4,500 years of erosion has taken place in the area, and a majority of the erosion is probably from the Younger Dryas period, which is estimated in secular literature to be the end of the last ice age, where in the global flood it would have been about 1,000 years after the flood when you see a rapid melting of the glaciers in the north and south poles, which causes major erosion. The ice would be covering half of North America at least until it begins to melt, and then it would retreat back to the Alaska and Canada.